Thank you, Kennel. Welcome back from lunch. I'm the enviable position of being the first speaker after lunch, so I hope I can get us off to a great start and get us refocused for this afternoon. Next slide, please. This chart should look familiar to you. It's very similar to one Rod Jones presented yesterday morning in his opening overview. And tomorrow we're going to be providing a lot of information to you to make you more familiar with the overall strategic payload planning and tactical mission integration process, how the real-time operations are conducted, and how the post-flight operations are conducted. And as you're learning about it, you're also going to learn things that you as a payload developer will need to provide into the system for overall success of your integration and research. And the payload implementation partner services we're all offering are made available to help you bridge that gap. We all want to help you in any way possible so that you can get your research on board. Now, why would you want to partner with Boeing? Next slide, please. This chart provides a very high-level overview of the experience we have in-house based on the role we currently play with NASA on International Space Station. If you look in the upper left-hand side of this graphic, payload systems development and sustaining engineering, Boeing was responsible for the design, development, and integration of many of the payload systems that are operating on board today. The Express Rack, the Wharf Rack, the Human Research Facility Rack, the Active Rack Isolation System, which is integrated with 2 of the onboard Express Racks, and it can be operated during your research periods to provide you a more quiescent microgravity environment. Boeing has also developed a lot of the flight software which is operating on board the avionics components today that will be routing your data all around the space station. And we have also developed simulations of that flight software architecture that we've made available to payload developers in the past for you to work with as you're developing your payload software. And we hope to add to our role in the very near future the sustaining engineering of the express logistics carriers that are on board Space Station for the attached payloads. Moving over to the right, as ISS payload integrator, Boeing supports NASA on a day-to-day basis for the ongoing ISS vehicle and payload systems development and payload integration work. So we have a lot of knowledge of the systems. We have a lot of knowledge of the systems interfaces to the payloads, and we're happy to provide those services, knowledge of that information to you as an implementation partner. You'll see at the bottom of the circle here the implementation partner services across the whole range of products that you'll hear people talking about today that we would also like to help you with as your needs exist. Okay, moving on to the next page. For the past year and a half, Boeing has specifically been working on a couple of products to make the overall task of integrating payload software easier. It's a very hard task and can involve a lot of time and involve a lot of resources. We call our toolkit that we want to make available to payload developers, we call it STELLA, an acronym for Software Toolkit for Ethernet Lab-like Architecture. There's a typo on here that I just noticed, of course. The best way to describe STELLA is if we first look at the graphics at the bottom. If you can conduct your research or analysis of your data that you obtain on Space Station using 2 computers that talk to each other with standard Ethernet protocols, STELLA can be of real help to you. If we look at the bottom left graphic, you'll see on the ground these 2 computers that might exist in your ground laboratory today in this configuration. You have your manager computer, which is running your experiment software. You send your controls and view your responses back from your research on that computer. You're talking over standard Ethernet protocols to another computer that can be controlling your hardware. It can be gathering information about the state of your hardware. It can also be gathering imagery data that you're collecting as part of your research. And if you're using standard Ethernet protocols, we can easily translate you to the space station operating in an express rack. Look over now to the bottom right graphic. Again, down at the very bottom, you can see yourself sitting there with your manager computer, running your experiment software just as you do today. There's a portion of the Stella software that will run along with your ground computer. And then look up high now. We have successfully helped you integrate your hardware in an express rack. You'll see your experiment on board. You'll also see your flight computer or flight controller running your experiment software, just like it does in your lab today. And you're also running a component of the Stella software on your flight computer as well. So your experiment software as it exists today talks to our toolkit. Our Stella software services then take over and handle all the complex data formatting, routing, packetizing that's required in order to communicate on the ISS command and data handling architecture. So Stella takes care of that for you. I might also note that on the ground laboratory side, Stella makes use of the NASA-developed Telescience Resource Kit. You've probably heard a little bit about Trek. You'll hear more tomorrow about how it's a pre-built interface for you to run from your remote location to interact with your payload on board. Also, to my implementation partner colleagues out in the audience as well, if you are looking at resurrecting some shuttle mid-deck hardware to support researchers coming to you, and you're looking at revisiting your payload software architecture to get it into an express rack, also please come talk with us. We'd really like to make Stella available to you as well. You know, our goal is to help everybody get their research on board. So we're happy to work with other implementation partners as well. Next slide, please. Our second product that we've been working on is called Raptor, and that's an acronym for the Remote Advanced Payload Test Rig. It's a portable computer environment that simulates the end-to-end ISS data architecture. You can use it during your software development and checkout phases before you get to your formal verification testing. It's very portable. You'll see it enclosed in that case that's shown in the top photograph. We send it out to you. You can use it where you are developing your flight hardware and software. We've put a lot of work into developing a very intuitive graphical user interface that you can use with this product. You can see a screenshot of it down there in the lower right. It essentially shows the Raptor unit as the larger green box in the middle. There's a Trek laptop computer icon connected in the system. There's also an Express Rack laptop shown in this particular example, and your payload is shown there on the right. To the very right of this snapshot, you'll see trim plots. As you're hooked up and you're flowing packets of data, commands and telemetry back through the simulated architecture provided by Raptor, you can see those trim plots updating as your packets are flowing. Very visual if your packets are not flowing as they should be. Raptor also provides a very advanced messaging system where we can give you feedback on any errors that were encountered, errors that the rack interface controller software on board would provide if there's a problem with your data, and we want to get rid of all that before we get up there. There's also a remote tie-in capability that we will have established where we could tie in remotely with you at your locations while you're going through your payload software development process. We have data probes that we can get to within Raptor to go capture your packets, analyze if there's something wrong with your packet formatting, and work with you to get all of your payload software interfaces properly ironed out before you show up for verification checkout. We will have Raptor available in 2011. And I might add, both of our Stella and Raptor products we have at our Boeing table in the stewing room. Please come by and visit us, and you can see them both working together. And one final thought is, although these two products right now are targeted for express subrack payloads, based on discussions we've had with people, we know there are tweaks we can make, enhancements we can provide to both products so that it supports express logistics carrier payloads as well, or payloads that will interface directly to the payload MDM system on board the ISS. So please come by and see us. Thank you.